Hey guys, I'm back. This is video part 2 of the same topic because I'm going to chop up my videos so I'll make sure they load properly and that they're not too large. Okay, let's pick up where we left off. Inverse trig functions, this is your part 2 video. How about this? Consider a compound expression because the last few examples we did only had like sine of a certain value. Now we have what are called compound expressions. Okay, consider this. If I ask you to evaluate the cosine of the inverse sine of 1/2, where you're going to start on the inside always, okay? You're going to start here and we're going to say, okay, what theta in the restricted area meets this requirement? Okay, so I want a theta that's in this area that has a y coordinate of positive 1/2. Well, in this quadrant 1 to quadrant 4 restricted area, there's only one theta that meets the requirement of having a sine value or a y coordinate of 1/2. So now essentially you are saying, now I figured out the inside and it is pi over 6. Okay, so now all you're going to be asking or telling me is what is the cosine of pi over 6? Well, the cosine of pi over 6 is the x coordinate at that same location. So the final evaluation would be radical 3/2. Okay, so you're going to start on the inside, work what you know about the inverse, and then you're going to find that theta, and then you're going to apply the outside ratio to that. Okay, so just kind of work from the inside out. All right, so radical 3/2 on that one. Okay, so we've talked a lot about sine and cosecant. Let's talk about now, in this video, we're going to talk a little bit more about the inverse to cosine. Okay, inverse cosine. Again, I'm going to start with the function. I'm going to graph the parent and we are going to talk about where is the function an absolute 1-to-1. Okay, so if we graph the parent, y equals cosine theta, amplitude of 1 and -1, and you know the increments are pi over 2. So we set it up and we say, okay, I'm going to graph the parent function and I'm going to find the first available part of that function where it passes the horizontal line test. Well, that would be from 0 all the way to pi, because from here to here, this horizontal instrument along this yellow portion is going to fully pass the 1-to-1. So we're talking about from 0, okay, to pi. All right, so you just nailed the restricted area for cosine and secant inverses. It is going to be quadrant 1 and quadrant 2, from 0 to pi. All right, that's the area that you're going to remain in if you're looking for inverse cosine or arc cosine, and secant inverse and arc secant. You're going to be in here. The same principles apply, the same routine applies. Okay, so again, that's where these restricted values come from, is the behavior of that function. We have to specify that inverse cosine has an inverse if and only if it lies within the region from 0 to pi. All right, so we're going to consider this. Say we want to evaluate the inverse cosine -1/2. All right, so in your mind, it's saying where in the restricted area for inverse cosine is an x coordinate, because we're talking about cosine, okay, the cosine value of theta is equal to -1/2. So you say, okay, I have to stay in my restricted area. I know that's going to be quadrant 1 and quadrant 2. I'm going to come from 0 to pi, and somewhere there is a theta that has an x coordinate, because cosine is x, of -1/2. Well, if you go around and use your unit circle or not, then you're going to recognize that a 1/2 in the front always implies a radical, a pi over 3 family member. So we go around, and at 2 pi over 3, we have found what we were looking for. It is in the correct restricted areas, number 1. Number 2, it has exactly the cosine value that we're looking for. So the answer here is you would give me the theta of 2 pi over 3. Okay, so 2 pi over 3, and we're going in a positive direction, so it's 2 pi over 3, and that's in the second quadrant. Okay, now let's evaluate this guy. The sine of the cosine inverse radical 2/2. Oh, excuse me, yeah, radical 2/2. So remember, we start on the inside. So in this restricted region, I'm looking for a theta that gives me a cosine value of positive radical 2/2. Well, according to your unit circle, positive radical 2/2 as an x is going to fall in this quadrant, and it's going to be assigned to pi over 4. So the inside statement is now evaluated at pi over 4. Then you're going to work to the outside and you say, okay, at pi over 4, what is the sign value? Well, it just happens to be radical 2 over 2. So your evaluation there was a compound expression. We started with the inside using what we know about inverse, and then we applied it to the outside. All right, that's all there is to that, okay? All right, let's go to tangent. Okay, now, you learned how to graph these yesterday, at least you better have. All right, tangent's one-to-oneness in the parent occurs between the two illegal values for tangent, and on the unit circle at 12 o'clock and at 6 o'clock, at pi over 2 and negative pi over 2, you find that tangent's undefined. That's why we have asymptotes there, okay? In the parent function, okay, we have no bx plus c in here, so that's normally what you would set equal to negative pi over 2 and pi over 2 to define your asymptotes. But since this was the parent, it's easily stated that negative pi over 2 and pi over 2 are our restricted asymptotes. And our tangent function snakes in between those. Well, it just so happens the horizontal line test, the tangent function passes entirely between these asymptotes. It passes the one-to-one. So guess what? The restricted area for inverse tan is just like the inverse for sine, okay? So it's going to be from positive pi over 2 to negative pi over 2 for these reasons. That's where it is a one-to-one function, and we are allowed to find the inverse of the behavior when it's one-to-one, as long as we slice out the interval. Okay, so what that means now is this is going to look just like the restricted area for sine. All right, so in a nutshell, here's what we've got. Okay, we've got our distinct areas. This area, quadrant 1 and quadrant 2, is reserved for inverse sine and inverse cosecant, and inverse tangent and inverse cotangent. Again, if you see arcsine, there's a C there. If you see arcsine and arcsecant, arctan and arccotan means the exact same thing. Okay, so you're restricted in here. All right, cosine and secant, they go together. They are reserved for the quadrant 1 and quadrant 2 areas from 0 to pi. And that also goes if you see arc cosecant or arcsecant. It means the exact same thing. Okay, so those are the inverse functions of the unit circle thetas that we are familiar with. All right, and we know the coordinates, and we know the radical 2 over 2, etc., etc. All right, I'm going to move to another skill here. Same topic. All right, so what if you're looking through your evaluation problems and you realize that, whoa, it does not look familiar. What if it's not a familiar ratio like radical 3 over 2 or 1/2 or radical 2 over 2 or even 1 and negative 1? All the ones that we're very familiar with on the unit circle. The answer, you have to sketch a triangle in one of the restricted quadrants and you're going to find what's missing. Okay? So for example, I'm going to give you something like this. It's compound expression. I want you to find or evaluate the sine of the inverse cosine of 1 over radical 5. You're like, hold up, Miss Smith. I don't know what this is. It's not one of my normal dudes. You are correct. But guess what? You're going to sketch a triangle, and you're going to sketch a triangle in the quadrant that's legal for that particular inverse function. So here's what we're going to do. I'm going to change pages. Okay, again. So the problem said find the sine, and then inside you've got inverse cosine 1 over radical 5. Now remember, you can rewind and pause this video as much as you need to get any of the information. All right, you're going to start on the inside of the braces, just like we did on the last one, okay? You're going to start in here, and you're going to say, okay, restricted over 0 to pi. So you know that you're going to be on the top half of the unit circle, quadrant 1 or quadrant 2. You're going to sketch a triangle. In this case, cosine is a positive 1 over radical 5. Well, if I'm limited to quadrant 1 and quadrant 4, then cosine, based on a smart trig class, it's going to be positive here. So I'm working in quadrant 1, so that's where my sketch goes. Number 2, you know you got a sketch, so you look at what you've got in your hand. You've got cosine. Well, according to your trig ratio sheet or your formula sheet, that is your x divided by your r, or your radius. So we're going to set it up as such. We're going to say my x is positive 1, my radius is square root of 5, and here's my vertical. I don't have that, but I need that. Why do I need that? Because my next application is going to be to find the sine value. All right, so we have to sketch this, and all you do is you draw a picture. Now we need to figure out what y is. Well, we can find y by using that shortcut formula. Y is equal to the square root of r squared minus x squared. I do the math. That's my r. That's my x. I end up with the y equals the square root of 4, and that's going to be positive 2. And it's a positive 2 because I'm in quadrant 1, right? And vertical is positive here. So y equals 2. All right, now we need to construct sine. Well, sine is y divided by r. Okay, so now if sine is y divided by r, I take my newly found y, which is 2, and we place it over the r, which is radical 5. And yes, I expect your final answers to be fully rationalized. I don't care what the original problem did. I don't care that they did that. It's a good thing that they did that because it's going to save us from having to double rationalize. So you will rationalize your final answer, okay? And in this case, the absolute ending answer is 2 radical 5 over 5. Okay, so again, this is going to occur when you have something here that you don't recognize, you haven't memorized. So you're going to sketch the triangle, you're going to resort to the restricted areas. You're going to determine, okay, of the restricted areas, I'm limited to 2 quadrants. Which quadrant is mine going into? Well, in this case, we knew it was quadrant 1 because my cosine value was a positive 1 over radical 5. So I sketch my little triangle. I know that cosine is x divided by r. So there's my x, there's my r. I label them, and I use this formula to find my y value. Once I found my y equals 2, I was able to structure sine, because sine is y divided by r, which is no more than 2 divided by radical 5, and then I rationalize. So again, 2 radical 5 over 5. You can do this for any of the unknowns that are not normal. Okay, so now your assignment is to print out the attached sheet on level 1 or day 1, whatever it is I called it, and you are to work the odds. No calculator, except there's a couple of problems that says you can use your calculator and there's a bunch of decimals. You're welcome to use your calculator on that and use your second key. The rest of them, no calculator. You're going to just sketch a triangle or you're going to use your unit circle. Okay? All right, I expect to see those turned into me via either email or scan, or take a picture of it and send it to me. Make sure you sign it with your pledge, your perfect signature, which vows to me that you are not cheating. And I'm going to take a daily grade from now on. That's what we've been instructed to do. Okay, guys, have a great night, and I'll catch up with you tomorrow.